Hello, everyone. Welcome to today's Future of Data in Austin Meetup. My name is Mark Shoney. I'm part of the user marketing team here at Cloudera. User marketing team, we create content for people that use the Cloudera platform, so technical content to help you learn how to use CDP, for example. And I've got some other folks from the team here. I have Tui, Bill, and Shelby in the back helping out with the logistics of this all. And then we have Nicholas Pelez, who's going to be presenting for you today's topic, which is enriching data using PySpark and Hive in a cloud environment. Really cool stuff. Now, I know some of you came here today for the content, but others of you came for the prizes. So if we move on to the next screen here, we don't really have a first place or second place. It's really just two winners. So on the left side, first winner is going to get that Elements Tea and those three other prizes there. That Elements Tea I've been looking for everywhere. It's highly sought after. It's always running out. So really lucky if you get that. And also look at that hoodie. I mean, you can't have enough. You got to switch them out every day, right? Second winner, you're going to get two T-shirts, another water bottle because you never have enough. They have to fall out of your cabinet, right? And that JBL clip speaker, perfect for grilling in Austin. I know I listen to ska all the time whenever I grill. Anyway, those prizes are going to be raffled off at the end of today's session. So after the Q&A, after we go through it, we want to make sure you stick around. So stick around so you can get your prize. You have to be here to actually get the prize. Now, I'm sure you didn't come to hear me talk, right? You came here for our presentation today. So let's bring in Nicholas Pelez. I call him Nick. Hey, how's it going?
Hey, thanks for having me.
Right. Nick and I go way back. We used to do analytics on engines together. Not as exciting as it sounds. We didn't actually get to see the engines all that much. It was kind of like the Matrix. You would see a bunch of numbers, and then in your head, you would know what was going on. So excited to have you present to us today. I'm just going to go ahead and hand it over to you. Why don't you tell us what we're talking about?
Yeah, sure. So thanks for the introduction. Like Mark said, we go way back. We used to do a lot of analysis on jet engine data for a lot of different fleets. So basically, our job was both to be data stewards, right, to bring it all in, to write all the processes that clean it up, and then to actually do the analysis and report out whenever anything was, wrong or irregular with an engine. And that's actually going to run similar to a theme that we're going to cover today. So today we're going to be going over how to do data enrichment, and specifically we're going to be using PySpark, and we're going to be doing it all within CDP, the Cloudera Data Platform. So if we could just move over to the presentation. Cool. So first we're just going to set the stage a little bit, give a little background as to, the reason that we're doing all of this and what we're going to show. We're going to then go into a live demo where you're going to get to see it actually happen. And then we'll loop back, we'll do a quick review, and we'll give you guys a chance to ask a bunch of really good questions. Historically, that's probably my favorite part of this whole thing. You guys have awesome questions, and they're really fun to answer. So without further ado, let's just jump into it. So today we're going to be putting ourselves in the shoes of an electric car company. All right, this car company is a vertically integrated company where they make all their own parts, they make all their own cars, right? And specifically today, the mentality is that this company is developing a new electric motor, right? And being that it is the most expensive part that goes into their cars, they really want to make sure that they follow and track all the data that goes around this motor as it's released into the field, right? So in our case, we're going to really just need to gather all the data around this motor that we can, bring it all together, enrich it, and come up with a data set that's, good at the end that we can use for further analysis. So a quick look at the data that we're going to have available to us. So I've kind of broken this out into three different subsections. We'll call them databases for now, but they're just kind of where different data would be siloed. In this case, on the left, we got factory data. So factory data is going to include things like parts manufacturing. So what part was made in what factory, on what day, out of what machine. We have car part installations. So once these parts actually make their way into a vehicle, we take that information down. So, this part was put into this VIN number of this vehicle, right? we have a specific subset of information that relates just to the experimental motor data. We knew that rolling this motor out was going to be a big lift for the company, so we kind of thought ahead a little bit, and we have just the specific motor data from the factories, right? We also have sales data, so when a car actually gets sold, we have access to who it was sold to, what model of a car it was, the sale price, things like that. Then we have the sale customer. I think I kind of just covered that a little bit, which is you got to know who that car was actually sold to. Then the marketing side, we have specific information about these customers, right? Just general things that you would get from a customer when they sign up for your website, things like your name, your address, and we have age, gender, occupation, salary, all this good stuff. Just a quick disclaimer, all of the data you're looking at has been synthesized, so I am not sharing with you real-life customer data. This has all been created for this demo specifically. And then the last thing we have in the marketing data is geolocation data. So turns out that when it comes to actually doing analysis on things, having a zip code or an address is not very useful for visualization purposes because it doesn't tie to a location in a very easy to track way. So what we actually have is a cross-reference where it'll take postal codes and it'll actually do its best to estimate a longitude and a latitude. And that's going to come in handy later on. So what are we going to do with this data, right? Our goal here is to take all these different data sources and to pull them together, right? And come up with a new enriched data set that lets us easily tell multiple different things about this specific goal. In this case, it's to track these experimental motors that are going out, and lets us do it in an easy way that you don't have to have people that are super experienced at SQL to make all these join statements, create views and everything against it. It's just one ready to go data set. And we want to do it in a way that this process can be run again and again, right? So we don't live in a snapshot of time, right? This company would ideally be selling cars that have these motors every single day, right? So you could theoretically run this code overnight and every single day have an updated, enriched data set that your data analyst or data scientist can go and they can actually come up with answers or come up with very interesting insights into how these motors are rolling out into the field. So how are we going to do this? Well, we're going to be using Cloudera Data Engineering, right, in order to do all this transformation. Cloudera Data Engineering is super useful because it allows you to kind of make your own environments and containers in order to which to run your code. And you can actually give it specific resources that you want to apply to it, let it scale. You have a really nice place where you can do some visual troubleshooting so that you can actually see if your code's taking a long time. If it is, why is it taking a long time? What steps is it kind of getting hung up on? It integrates Apache Airflow, and it manages serverless Spark. So everything we're going to be doing today is going to be Spark, and it's going to actually be in Python. So we're going to be using PySpark to do all of our data transformations and all of our database writes and reads and stuff. And then all of this is going to run inside the Cloudera Data Platform, right? In this case, CDP public cloud. The Cloudera Data Platform is a hybrid multi-cloud platform. It lets you operate both on services in the cloud or on-prem or a mix of the two. It does everything from ingest to data engineering to warehousing to machine learning, all the way to security and governance, right? That's what SDX is. That's what it stands for, our shared data experience. So it basically gives you a place where you can do just about anything that involves data and lets you do it all in a secure way where you can control everything really easily. So without further ado, let's actually see it in action. All right. So if you were to open up CDP Public Cloud for the first time or the 100th time, this is the homepage you're greeted with, right? On the top row, you'll see there's a bunch of different icons. These represent our different experiences, right? You've got Data Hub clusters, data engineering, data warehouse, operational database, machine learning. At the bottom, you've got what we call the control plane, which is where you can adjust certain things about your environment and where you're working. In this case, we're going to be looking at a few of these experiences and how they kind of tie together. So starting on the left, we have Data Hub clusters. That's more like the traditional deployment of Cloudera. It basically allows you to spool up data hubs that do specific templates that are set up to do specific things. In our case, we have used it in a previous step in order to load our data. We used NiFi, a data hub that's spooled up for NiFi, and we'll go into that in a second. Data engineering is where we're going to be spending most of our time, right? That is the data engineering experience where it lets us create virtual clusters where we can actually run and execute Spark jobs. We're going to be taking a little peek into the data warehouse because that's where data is both being pulled from and ultimately being stored to, as well as we're going to use it to visualize some of our data. So that's going to be pretty cool. And for the other ones, stay tuned. We will do future meetups that go over our operational database and how to, write some cool, interesting applications against it, as well as a bunch of cool machine learning stuff. As a little bonus, that raffle that we're going to run at the end to select your prizes, that is actually hosted in Cloudera Machine Learning. So all that code is running within the same platform. So let's go ahead and get started. So the first thing that I kind of want to just dip into really quickly is where this data originated from. So what I'm going into here is a data hub. This data hub has been spooled up with the data flow template, which houses NiFi. So we can actually go into NiFi really quickly. And in a previous meetup, and we're kind of going through the whole data lifecycle in a series of meetups, as well as Cloudera Now. Shameless plug, which is in 2 days. So go check that out. You'll see all of these. But in this previous meetup, what we've basically done is we took a year's worth of data from our integrated electric company, right? Electric car company. And we just dumped the file in S3, right? In a CSV. And what we did in NiFi is we actually pulled that year's worth of data out of an S3 bucket. We split it up per factory and we sent it off into individual factory streams. This is kind of to simulate a real world use case, right? Where you wouldn't have one centralized point of data, but rather you'd be picking it up from a bunch of different, places. In this case, 5 different factories, right? And you'll see that these factory streams are here going off on the right-hand side. And in another flow, we actually collect the data from these streams. And we do a little bit of filtering and enrichment here. Now, this is very low level. What we're doing here actually is we are looking for the specific experimental motor data. So if you see here, we have, this is what's called a query processor, and it lets you query data as if you were writing SQL against it. And all we're saying is, if this data has a part number of a certain, identity and comes from a specific factory, then we know that this is an experimental motor. So we're going to take this specific data and we're going to shuffle it off into a different route. Right? Well, we're going to save all that to Hive. The reason we're doing that is because over the course of a year, this company has created millions of parts, right? And all that data still needs to be stored in case we want to look at that. And we're using HBase for that. But in our specific case, we know that we want to take a closer look at the experimental motor. So we're going to break that much smaller subset of data off and save it into Hive so that users could write ad hoc queries against it much easier than you could against something like HBase. So I just want to kind of set the stage a little bit. That's where the experimental motor data originally comes from. So if we go back to our Cloudera Data Platform, so now let's go into data engineering and let's start seeing some of the magic that we're going to do today. So when you go into Cloudera Data Engineering, you've got kind of 2 main sections here. On the left, you have CDE services, and on the right, you've got virtual clusters. So what your CDE services are basically your overall environment, which is like a bigger bucket that contains all of the users and all the permissions and things that you want to control. And you can actually go and look into the one that I've set up. It lets you set the workload type. So, what kind of work are you going to be doing? It affects what kind of resources are attached to this environment, the size that you potentially need, the auto scale range. So things will auto scale up and down. In our case, our workload is going to be relatively light, so we're not going to see any auto scaling here. Enable the public endpoint, lets you add some tags. And at a high level view, also, it gives you really quick insight into what's running, what isn't, how many jobs, how many nodes you have going, right? It's like a quick visual representation of everything going on. It's actually pretty interesting. So with that spooled up, you can now create virtual clusters within that environment. This is like more fine-grained control, and we'll go and pretend like we're going to make one. I've already made one, but just in case, right? You would give it a name, and then you could say how many cores for CPU you would like it to auto scale to, and how much memory you'd like it to auto scale to, the service that it belongs to, and this just lets you basically set resource allocation depending on what you're trying to do. So you may have a specific group that runs nightly jobs that take a ton of resources, right? But they only run for an hour or two a night. Whereas you have other jobs that are meant to be running every minute or two, but are much lighter on resources, right? You can set the auto scaling to represent that. And that way, if anything goes out of whack, right, you know what is going on. You have guardrails, you have limits. Your process that runs every minute won't all of a sudden be taking up 300 cores and you won't know why, right? So in our case, we've spooled up a VPC called Electric Car Company VPC. And let's actually go into it and see what we can do. So being that this is a newly created VPC, you are greeted with, welcome. Let's get started by creating a new job. All right. So before we create these jobs, let's just quickly talk about what these jobs are actually going to do. So if we just open up this code real quick, hopefully this is legible. We're going to be running 2 PySpark jobs today. The first PySpark job is going to be like a presetup job. So the data that I showed you earlier that came in through NiFi, that was only for the experimental motor data. The other factory data, customer data, and sales data, we have loaded in S3, but we haven't loaded it yet into Hive. So we're going to actually use data engineering to load this data, right? It's very, very easy, and it's actually just like a cool representation of something that it is capable of, right? So this one's very simple, right? We set some configurations in the beginning, and we basically give it 5 different tables that we're looking to load. This is the bucket name that we have placed them in, and this is the CSVs that we have saved, right? And in order to bring data in, right, this is a data frame object here, car installs. All we have to do here is do a Spark, read, CSV, give it the bucket name, give it the name of the CSV, and it will grab that file, it will load it into memory. And now we have a data frame object called car installs that has all the data that the CSV has in it, right? Super easy. We're going to do some cleanup just in case that things already exist. So we're going to just run some quick SQL statements, right? We're dropping any databases if they already exist. We're recreating them. And then all we're doing is, again, on our data frame object, we're doing a car sales.write, mode overwrite just in case something already exists. It shouldn't. We deleted everything, but just in case. And then we're saving it as a table, and we're calling it sales, car sales, right? And so on and so forth for the next 5 tables. So let's actually look and see at how this runs and how we start this up. So let's go to create a job. Now we'll see we have some options here, right? We can either do a Spark job or an Airflow job. In our case, we're doing Spark, right? So a name, we're going to do load data warehouse. We're going to choose a file. Presetup data warehouse is what we call this. So let's go load. Here you can feed it opening arguments if you would like. Our code doesn't need any. Configs as well. We're good on that regard. We're running Python 3. You can actually do advanced options if you'd like, which basically lets you set specific limits on resources that you want to allocate to this job, right? And any other dependencies, the log level. We're going to leave that alone for now. We can also set this job to run on a schedule. In this case, we just want this job to run once, but if you wanted to run it every minute, every hour, every Sunday between 9 and 10 p.m., you could do that here. You can also make this job dependent on a previous job, right? So, if you need things that trigger in order, that's where you could do this. Again, we're just running this once, so we're just going to hit create and run. So now this job has spooled off, right? It's off and running. I want to just hop back over real quick and show you where this data is going to end up. So if we go back to CDP public cloud, we have data warehouse. Within our data warehouse, right, we have an environment that we have spooled up. It's similar to the data engineering environment. It's kind of where all your permissions and you can manage all of the security and stuff. Within that, we have a database catalog. This is where your actual data resides. And within that database catalog, we have spooled up a virtual warehouse. The virtual warehouse houses just the virtual compute resources that let you interact with the data that you have saved in a database catalog. So what's happening right now is that Spark job is writing our data into this database catalog, right? And we can access it through this virtual warehouse once it's there. So let's go back over to our job. And as it's running, right, you can actually go and you can look at the logs, right? So just in case you want to monitor where it's at, we've given ourselves a few standard outs, right? So you can see that the job has started. And as it goes, this will actually live update. And this should only take about another couple seconds. So while we're waiting on that, let's open up where we can look at the data to make sure that it landed. So let's see if this finished. Almost there. Okay. While we wait on that, let's go and start looking over the next code that we're going to run. So this is the actual ETL job that we are going to run against our data once it exists. So here it gets a little bit more interesting. So the first thing that we're going to do in this code is basically read out the data that we've written into these Hive tables, right? Now you'll see in this case, we are no longer reading from a CSV, right? We are doing a spark.sql and we are selecting from the tables that we have written to, right? Here, it is just like any other SQL syntax. So if you want to rename some columns, some fields, right, even just on import, this is a pretty easy, quick way to do it. In this case, you'll see that we took zip and we renamed it to, or we took postal code, we renamed it to zip from this georeference data, and the rest of them we just left default. So once we've got data into memory, into these data frames, the next thing we're going to do is actually apply some filters. Anyone that's worked with a lot of data will tell you that very, very rarely is the data set that you get clean and beautiful and ready to work with. Almost always there's going to be a step where you have to clean and you have to filter and you have to get rid of irrelevant data, right? Mark, I'm sure will tell you in our previous job, I would say that a solid 60% of the data that came in had to be massaged, manipulated, deleted, right? It was just as much data custodian work as it was analytics. And bad data will throw off your answers, right? So you can't make inferences based on data that's not clean because they might just be wrong, right? They might not be representative of what you're looking at. So in our case, we're going to do a very simple filter. For better or worse, since the data was synthesized, there's not a ton of garbage, but something that we overlooked when making the data was that this is a car company, and we randomized the customers. Some of those customers are under 16 years old, right? Well, you can't rightfully buy or drive a car under 16. So what we're going to do here is we are actually going to just do a quick filter, and we're going to get rid of any customers that were born within the last 16 years, right? And that's what you're seeing this in just one line, right? We're taking customer data and we're filtering it by birth date. If it's less than 192 months from today, we are getting rid of that data, right? And that's all it takes. It's just a one-liner. And then right after, we're giving ourselves a little print statement here so that we know how many records do we have before, how many do we have after, so we know how many people we filtered out, right? Just to make sure that everything's working right. So once that data is filtered out, right, we are going to start taking all of the disparate data and bringing it together, right? Now, traditionally, if you were doing this in like a relational database, you'd be sitting there and just, writing a bunch of joins based on your keys. This is a little bit better, a little bit more object-oriented, and also you have both options available to you. So in this first case, right, you'll see that we wrote SQL type syntax that simply does a join on a key, right? So we're selecting customers, and we are selecting sales, right? So we are basically joining car sales data into customer data so that we know what customer bought which car. It's a pretty simple join. We've got a customer ID. We're bringing them together. And with that comes a new table, right, that has the join data together, right? So then we're just going to do some quick print statements. Again, this is just for if you're looking at the log files, it just lets you know where you're at in the code, if everything worked right, if you're happy. And we're actually going to follow that through, right? So next, we're going to join in the geolocation data. But we're going to join this data in a slightly different way, right? Whereas before, we ran a spark.sql job that had our SQL syntax of a join in here. In this case, we are actually going to just use the data frame method join, right? And we're going to give it the other table that we want to join against and the key that we want to join it with. And it's that easy, right? So we've now kind of covered two different ways, right? You could do an SQL way if that's just what fits your style, if that's what you know better. Or if you want to be a little bit more object-oriented, programmatic, you can actually just do it via the join method on the data frame. It works also with multiple keys, right? So in this case, we needed to join on both VIN and model, right? And we are joining all of the data together, right? With the goal, again, of getting a table that has everything available to you, right? So the final join's bringing in factory data, which makes it so that now you have what car was sold to whom, what motor is in it, where it was sold to, what factory, what machine, and what day that motor was made on, right? And now we're going to take that finalized table and we're going to save it into a new table in Hive. We're going to call factory.experimental motors enriched, right? So now let's go back to data engineering. We'll see that our job ran successfully. Actually, this little check mark means that we're happy. If we click the run ID, we can see it took 1.8 minutes. We can look at the logs. We can see that our comments are in here, right? And we're going to look at the analysis in a second, but for now, let's create this new job. This is going to be our, we'll call it enrich ETL. And we're going to load the code that we just looked at. Again, we're not going on advanced options here. We're not scheduling this job. We just want to run it once. We have no arguments. So we'll just create and run. And now let's go look at our load data warehouse job run. And you can see that it'll actually give you a visual breakdown, right, of all the different stages that it went through, how long they took, the input, the output size, right? Things like how much memory was taken at the time, how many cores were being used, right? You see our memory usage never went over a gig. These files are pretty small, fortunately. you can actually run a deep analysis that takes a little bit, so we won't be showing it here, but the point of that is that if you have a very either intricate or a job that is giving you trouble and you want actually to take a deeper dive into it, say something that runs every hour and it's a very, very heavy lift and you want to be able to optimize it, right? That's when you do something like run a deep analysis and find yourself places to optimize the code. In our case, we don't necessarily need to do that. So now if we go to the job that we currently have running, right, we left ourselves a whole lot of comments. So, hopefully if we go to the standard out, we can actually watch this log file as it goes. So we have job started. If we scroll to our code, right, this is the first thing. So now it's reading from all these tables. After that, you should see, read tables complete. So while we're waiting for this to go, let's actually dive real quick and make sure that our data actually exists. So, instead of jumping over this tab, let's do it the right way. So again, we're going home, we're going into our data warehouse, right? We're going to open up this tool. We're going to write a quick query against our Hive data, right? So if we just do a simple select star, and let me just remember what the factory table installs. This, you'll see that our data did successfully load, right? And we can look at it here in tabular format. That's great and all, but we could do a little better. So now that this job run is finished, let's go look at the logs. You'll see that we left ourselves a bunch of comments. We can see as the data evolves, right? So this is the first table that we got. As we start joining data into it, right? So this is just the customer. This is just the car sales information. Here you have the car sales as well as the customer data, right? Again, all of these customer names, ages, everything, all made up. So we're not actually showing you real customers. And you can see, right, as we go, we get more and we get more and we get more data in until we end up with a final enriched table. That doesn't look super pretty, right? So let's just go look at it somewhere that's going to look better. Let's actually, a second. Right here, we can prove to ourselves that this data did make it into our data warehouse, right? It's all right here. And that's great. Right now, our data scientists can pick this up. They can write queries against it. In our specific kind of idea of why this matters, right? Let's say that you had a manufacturing defect, right? And you know that for these experimental motors, you had a bad batch of materials go into your factory. And it only affected a week's worth of production, right? But that week's worth of production, those motors are much more likely to fail within a short amount of time, right? What this lets you do is tie all of the data together, right? So you can actually easily write a query that says, give me all of the cars that these motors went into in this span of a week. And now you could track them and you know exactly where they are, who has them. You could send out repairs to any kind of repair facilities nearby, right? And you can actually visualize something like this. So I've taken this data, and since we have geolocation data, I've thrown it into one of our visualization tools, right? This is also built into our data warehouse. So what you could ultimately do is have a dashboard like this that says, hey, for all of our experimental motors, this is where they are, right? And if you want to narrow it down by a certain week, you can. And now you can preemptively go and tell people, hey, we've had a little hiccup in our manufacturing process, but don't worry, we've got parts already on their way, right? You just need to send your car to the service facility. Since we know it's already an issue, they'll get you in and out in a couple hours. You won't have any downtime. It'll be great, right? The other case is that you don't have access to any of this data. someone comes and tells you that a week's worth of supplies were bad, and all of a sudden you're sitting there going, wow, I really hope that those people don't get really mad at us when their car leaves them stranded on the highway 40 miles from home and they have to get it towed. So that kind of rounds out the end of the demo. I will bring us back for a Q&A.
Hey, looks like I'm back. Nick, that story about getting stuck 40 miles from home sounds a little too real. That that happened to you anytime recently? Oh, you're on mute, Nick. Gotta switch back.
Thank you for
Yeah,
that.
no problem.
Yeah, my car is not electric. I wish it were, but no, it definitely left me stranded right around 40 miles from home with no clutch.
Yeah, that must have been a long tow ride.
It was.
Anyway, welcome to the Q&A part of our session. Send in your questions. We'd love to answer them. We'll try to answer them to the best of our abilities. It can be it could be technical questions. It can be questions about the demo. It could be more about the Cloudera platform in general. Send them in. We'll get through them and we'll try to answer them to a level that is acceptable. So, without further ado, actually, some things I want to kind of bring up there. Nick, when you're showing that data in Hive in the query editor, something that I just kind of wanted to note is that you could, for example, mask some of that data there because there was a lot of customer data that you were showing, and you may not want your data scientists to see it all, right? So you may want to mask maybe street addresses or other kind of personally identifiable information so that it's not just clear out into the world. So
Yeah, and you hit the nail on the head on that one. And actually, we will have a meetup showing exactly that. So part of our data lifecycle here is SDX, right? The shared data experience. And like Mark was saying, that allows you to put attribute-based access control. That's the right word, right? And so you can actually show, part of our demo will be that we have a super user, right, like me, who can see everything. And you saw, all the customer information and stuff. But you can also set up so that individual users are less privileged and they can't see sensitive customer data, right? So instead of seeing, Nicholas Palez at company.com, right, they're just going to see maybe the first two letters and everything else will be starred out. They won't see anything like salaries or age or address. And it kind of lets you secure the data so that only the people that should see it can see it.
right. And so one more thing before we get to the public's questions is so I saw that you were kind of running those jobs manually, but also CDE has the ability to use Airflow, right? So that you can actually make jobs dependent on each other. You can, for example, set up a schedule so it's running once a day, once an hour, but you can make sure that the first step of that job was running before and the second step won't run before that.
Right. And another thing that I forgot to bring up, so thanks for reminding me, is that all of these virtual clusters have a CLI and an API that you can hit them with, right? So while I showed you the user interface way to interact with it, because it's the most visual and kind of the most fun to show at least, you can also very much hit this via the command line, right? Or via an API. So if you have some kind of continuous integration going, or you're developing locally or somewhere else, right? And you want to simply push your newest job out there, you don't have to open up the user interface to interact with this, right? You can simply run commands that go I know on my other computer, right? I have it set up where my Visual Studio Code actually has an extension that runs a series of commands whenever I save a Python file. And those series of commands simply talked to CDE and they say, okay, is this a Python job? It is. All right, cool. What's the name of it? All right, let's submit that as a job and let's shoot it off immediately and give me the results of how long it took to execute. So it's all, I don't have to do any of that graphic, that UI stuff. I basically just hit save and it goes and runs.
And actually, I'm seeing a question coming right now from Habib. I hope I said that right. I'm terrible at pronouncing names, but asking more about the Airflow integration. And I don't know that extensive about it or that much about it, but I do know that you can actually even get to the underlying code, right? So like you can set it up in the UI, and then you can actually go in and programmatically change some of the airflow settings behind there. Nick, I don't know if you know more about it or you've seen that part of the demo before, but I've seen like our PM do that before, where they've actually set it up at the beginning and then they made a more complex job where you could even make it dependent on more than one job in the past and things like that.
Yeah, I don't have anything to add to that, but yeah, I mean, you can actually go through and edit
Yeah,
everything in the back end. Yeah.
you can get as complex as you want with it. The idea is like CDP, they try to make it easy, right? But if you really want to dive in and go start coding things in yourself, then you have the ability to. So it can be as easy or complex as you want it to get. Here's another question from Future of Data, and I think it's a good one to hit on first. Why do we call things virtual clusters? And it's not just CDE, right? Like we have virtual in data warehouse, we have it in data engineering and other places. And I can kind of start that off. So the reason we're calling it virtual is because we have this notion of separating compute and storage in CDP. So for example, in data warehouse, your database catalogs, right? That's kind of where all your data is being stored. That's the storage element of it. And then you're creating these virtual machines for like virtual warehouses, right? That will be the compute that operates on that data. So Nick, I don't know if you want to expand any more on that.
Yeah, I mean, everything you said is true. I mean, the idea there, right, is that you can spool up or spool down resources and they're decoupled from your data, right? So if, for example, between 9 and 5 p.m., you've got people, and your company that are hammering away, right? They might need a lot of resources to do that. So you can spool up your virtual cluster that houses just the compute resources that lets them do that, right? But at night, right, 7 or 8 p.m. rolls around, you may not need those resources at all, right? The data has to stay there, right? Obviously, you're not going to destroy or create your data, but you can actually spool down those virtual resources. And that's, I think, why we call them, virtual compute, because it's virtual.
Yeah.
They can exist or they can be taken down, and they shouldn't affect your workflow very much.
It also helps with isolation. So like, for example, if I have if I have two queries that need to run against the same data set, right? I can isolate those two into two different virtual either warehouses or virtual compute clusters, and then they won't stomp on each other's resources. So there's a lot of kind of clever things that you can do with it. Let's go to the next question here. I want to make sure we don't run out of time. So from Tobias, how would I pass in credentials? For example, how would the script authenticate with S3? And I have a note here that I kind of want to bring up ID broker because that's one way that you can do that. But Nick, if you want to expand on that.
Well, no, I mean, I think you were going to hit on it. I'll let you take it because ID broker was going to be my answer. And
got it. Okay, yeah. So basically, you have your Cloudera users, right? And what you can do is you can map the users in CDP to, I'm just going to use AWS in this example because you brought up S3, to roles in your AWS account, right? So you can actually create a few different groups of roles that all have access to different types of either S3 buckets or directories within the S3 bucket. I always feel weird saying directory when it comes to object storage, but anyway, so, and then what you do is you map those users to the correct ARN, right? The correct Amazon resource, and then they will get permissions to that. So it can either be a real user or a machine user as well that will be mapped. And that's all done through ID broker on the environment level. So that's kind of the quick version of that. But of course, you can get more complex with it.
Right. And it sounds kind of complicated there, but CDP does most of the work there. So once your environment is set up, basically your AWS or Azure or Google Cloud, whatever you're using as your cloud infrastructure, those roles have already been established. And so within CDP, all you have to do is give yourself your ID, map basically the role to whatever user, right? So if I want to be able to access all the S3 buckets and stuff, right, I would give myself that permission. Whereas if somebody else maybe shouldn't have access to that, right, you can kind of control that within CDP itself.
Yeah. For example, just kind of hit it home. We have a user marketing bucket, right, with all of our example data. So we have a role that's tied to that user marketing bucket. It can't read any of the other ones. And so what we do is we have a group in CDP just for our team, and it has Nick and I in it. And we say tie this group to it takes like 2 minutes, not even. We say tie the user marketing group in CDP to this ARN in AWS, and then right away we have access to all those resources. Okay, moving on. Let's see. So Augusto, is it possible to use PySpark combining different data sources like files, Hive, Kudu, and operational database, or is it mandatory to have it first in the same back end? So I think what you're asking, Augusto, is can we use PySpark to access all of these different, really it's experiences, right? Like Hive and data warehouse, Kudu would be maybe in a data hub cluster and from operational database. And I believe the answer is you can use it, right? If you're in data engineering, you can use PySpark to access it all because CDP, it's all on the same platform. It's when you have an environment with all these different experiences spooled up, you can pull from whichever data sources. And Nick, I think you've done that before, right? Like you've pulled from OpDB using Phoenix.
Yep.
Yeah.
So yeah, anything that you can pull in through PySpark, you can do here, right? So as long as there is a way to communicate with, either HBase through the Phoenix layer, or if you want to do, Hive. We actually showed two different ones that you just said. We showed Hive and we showed S3 here, just in this demo. But anything you can run in PySpark, yeah, you can run in CDE. And the plus side is that usually, for the most part, authentication is taken care of for you, right? By the previous question, right, which is that your user inherits the permissions that you have set up in the environment as a whole, right? So it makes it really easy to go access things from, OpDB, or from like an HBase table, from Hive, from an S3 bucket that you've configured. It lets you pull from anywhere.
Got it. So moving on. From Lolo92, can you this is from YouTube, can you manage different Python environments like 3.6 and 3.7, but also with different sets of libraries like images are provided by IT? And I think this is getting to like virtual environments, right? Like how do we set up different virtual environments in not just CDE, you can do this in CML as well, which is the machine learning platform. But let's talk about data engineering since that's what we talked about today. You can upload your requirements.txt file, right, with all of your packages in there. And then when you create the job, and that will install all the right Python packages that you need. I don't remember, Nick, can you specify the version, like 3.6, 3.7?
I would assume so, but I can't give a good answer on that.
Yeah, in machine learning, you can. I definitely remember machine learning. You can actually create your own Docker images and add them in yourself. So you can create whichever type of environment you want to run from. In data engineering, I can't remember, but I do know that you can specify the packages that you want to build the virtual environment that runs your PySpark job in. So, all right, I'm just checking the time. We got a little bit more time left here. So follow up on the permissions. So how does the script know which user to use or what token? Nick, when you create that job, can you set which user the job is running as?
So at least through the UI, it uses whatever user you're logged into CDP as, right? So it used nples, which is my user. I know that if you are running it from elsewhere, from let's say the CLI, you can actually specify the username, and you can give it a password file, so that you can impersonate another user, or say a machine user if you want to do something like that. So the answer is, I guess, depends on how you interact with it. Via the UI, I believe that you are kind of limited to the user that you are logged in CDP as, but from elsewhere where you're authenticating, via username and password, then you can actually give it a different user.
Yeah, and speaking of the CLI, you actually did a cool thing I kind of wanted to bring up too, where you were so you use VS Code on your local machine, and then you were actually able to kind of debug, not in almost real time, the PySpark scripts, because you would write it out, and then you had some automation set up in VS Code that when you submit the job, it would run it right away in CDE. You'd be able to see like what happened, what went wrong, and then make your updates and then run it again. So, for example, in there you're using the CLI to in CDP to have that all work, and that's how you specified your endplays user, right?
Yep, exactly.
But if you want to run it as a machine user, that when you submit it through the CLI, that's how you would do it.
Right.
Yeah. Okay. Let's see. From Darvish, how does the storage from on-prem get used by virtual cluster? Do we need to copy that from on-prem to the cloud, or will that be fresh data only available in the cloud? Okay, so I can start this off. CDP is hybrid, right? I think we brought that up earlier. And so you're able to do things on-prem and in the public cloud. And we use something called Replication Manager to bring things from on-prem to in the public cloud. So that's highly dependent on how your setup is, right? Like if without CDP, you're already replicating data on-prem and in the cloud at the same time, you can just pull it from S3 storage. If you want to coordinate that all within CDP, you could use Replication Manager to take either full tables or subsets of data from on-prem and then pull it into the cloud. I'm trying to remember if there's a video showing some of this. I'm trying to remember what it was exactly called, but that just may be something we have to follow up on. But you can also set up, for example, I've seen on operational database, they set up replication between on-prem and so like HBase on-prem is replicating to HBase in the public cloud. And so they're able to replicate data that way. There's a few different ways that you can do it. And Nick, I'll give you some time if you've seen anything else or if you remember the video. I know there's some video out there that shows this, but I can't remember where it is. It's probably somewhere on YouTube.
Yeah, we do have a ton of videos up there just showing how to do like relatively basic stuff like this. A lot of these demos that you see also, we have little 5-minute, videos going, just walking you through it. As far as that video exactly, I don't recall which one you're talking about, but I'm sure it exists.
Yeah, the problem is I've seen so many videos, like either publicly or like I'm trying to remember where it was. I feel like I see a demo a day here at Cloudera. Okay. It looks like we're getting to that time. We're getting close to the time of the raffle. So some of you are going to win some prizes. Very exciting. But before we get to the prizes, I have to bring up just one more point for all of you. So if you enjoyed what you saw today, we have some follow-up places that you can go to. If you like seeing content from our team, we have the cloudera.com/users page. We create tutorials, videos, blogs. We mentioned YouTube, right? We have videos on YouTube there. So go check that out. Cloudera video tour, that's going to be more of a general overview of how CDP can help you through your data lifecycle. So from like ingest through what you saw today, enrichment, analyzing through warehouse, doing machine learning, and OptDB for actually operationalizing that data. Future of Data Meetup page, you can see the next meetups coming up. And we have Cloudera Now happening very soon. Go sign up for that. It's really cool. I always love the demos from there. It's some of the best ways to see how to use CDP, other than watching these meetups. And the next meetup we have coming up is Hello Impala, an introduction to the next generation of analytics. So if you like this meetup, go check that out. It should be very cool. So March 18th. All right, I think it's raffle time. Yeah, I'm gonna full screen here. Maybe I can read the names. Nick might have to do it for me. Make sure you switch your microphone, Nick, in case I can't read it.
I'm on it.
Okay. Oh, I can kind of read it. Okay.
All right. Do we need a drum roll, or you want to just go for it?
Why not? Go for it. I should add like little confetti things to this.
Too late. All right. There you go. Our first winner.
Yeah, you're gonna have to read that.
Is Lolo92.
Hey, congrats. Hey. I should get one of those like confetti cannon things for for the camera.
And let's see who our second winner is. Darvesh Kumar. Congratulations.
Awesome.
So,
Congratulations to both of you. I believe we'll have someone reach out to you. Otherwise, you can reach out to. Actually, let me figure that out quickly. Uh, Nick, if you know how this was done last time.
yeah, we'll reach out to them.
Got it. Perfect. Okay. We'll be reaching out to you so that you can collect your prizes. Congratulations to both of you. Thank you so much for joining today's stream. It was a lot of fun for us. Make sure you join the next one so that we can get even more questions next time. Uh, have a great day, everyone.